Good afternoon, everyone. I am Kausar Jasmine from Mechanical Second Year of SRAT College. Today, my topic is about process hardenability and surface hardening in heat treatment process. Hardenability, where the hardenability is the composition dependent property of a steel that describes its ability to harden by martensite formation and is related to parameters such as austenizing temperature, cooling rates after austenizing, and part size and geometry. Hardenability refers to the ability of a steel to harden in depth when subjected to a heat treatment process. It is a crucial property that determines how well a material can resist wear and tear deformation. Understanding hardenability helps in selecting appropriate heat treatment process for various applications. Process of hardenability. The hardenability is a ferrous alloy is measured by a geometry test. Geometry test around the material bar of standard size is transformed to 100% austenite through heat treatment process and is then quenched one end with room temperature water slides. Austenizing is a material is heated to an austenating temperature. Quenching. The material is rapidly cooled in a quenching medium such as water or oil. The cooling rate is highest at the quenched end of the material and decreases and as you move away. Measuring. A flat surface is ground on the material and the hardness is measured along the bar. The further away from the quenched end that the hardness ends, the higher the hardenability. These are the pictures of hardenability of steel. For example, hardenability of a steel is of a transformation of height fraction of martensite of depth of several millimeters under relatively slow cooling such as an oil quench, whereas a steel of low hardenability may only form millimeter even under a rapid quench. Here we can see factors affecting of hardenability. There are carbon content, allowing elements, quenching method, cooling rate, grain size, and we can add grain size, prior process, allowing elements, etc. What is carbon content? Higher carbon content makes steel stronger and higher but less ductile. Alloy elements. Other elements can increase hardenability by slowing down the formation of ferrite, bayonet, and perlite. Quenching method. The type of quench affects the cooling rate. Cooling rate. The faster the material cools, the less time the grains have to change, and the more likely the structure from formed during treatment is to be retained. Measurements of hardenability. Hardenability is a typically measured using standardized tests such as the Germany test. The Germany end quench test is the standard method for measuring the hardenability of steels. Heat and standard size round metal bar to be austenizing temperature. Quenching. One end of the bar is in room temperature water. Ground a flat surface on the bar, measures the hardness along the bar. Now plot the results. Hardenability. The Germany test involves quenching a heated steel specimen and measuring hardness at various distance and quenching end. The result provide a hardenability curve indicating how hardness varies with surface distance and cooling rate. Now coming to surface hardening overview. Surface hardening overview, we can see here what is surface hardening, applications of surface hardening, challenges of surface hardening. Let's see. Surface hardening. Coming to surface hardening is a heat treatment process that enhances the hardness of the outer layer of a material while maintaining the hardness of the outer layer a tougher coat. This technique is beneficial for components that require wear resistance on the surface but need to retain difficulty toughness internally. Surface hardness is a largely divided into three types. indentation hardness, durometer hardness, scratch hardness, more hardness, and material hardness, etc. Common methods for surface hardening include case hardening, induction hardening, and flame hardening. These are the pictures of surface hardening. Applications and hardenability and surface hardening. Hardenability and surface hardening are essential in manufacturing components like gates, shafts, and bearings. Manufacturing surface hardening is used to create part for machines, chains, scratches, fasteners, screws, engine crankshafts, rifle bolts, firing pins, and more. Construction, minings, and heavy machinery parts. This process enhance wear resistance, extending the lifespan of critical parts in machinery and vehicles. Industries such as automotive, aerospace, and manufacturing greatly benefits from optimized hardening techniques. Challenges in heat treatment. One of the main challenge in achieving desired hardenability is controlling the cooling rates during quenching. And fatigue strength also comes to the challenges in heat treatment, residential stresses, quenching conditions, and grain size is controlling the cooling rates during the stresses can affect the fatigue strength. Improper pot hardness cracking, improper patterns, quenching issues such as foaming or excessive drags out, corrosion issues, biological issues such as bacteria, fungus, or odors. Various variations in material compositions or heat treatment parameters can lead to inconsistent hardness profiles. Proper monitoring and adjustment of processes are essential to ensure uniform result and prevent defects. Conclusion and the future trends. The understanding of hardenability and surface hardening continues to evolve with advancements in material science. New technologies and alloys are being developed to improve hardening process and enhance material performance. Ongoing research aims to optimize heat treatment techniques from better efficiency and sustainability in manufacturing. This is about the process hardening and surface hardening. Thank you and have a nice day.